Hey, welcome back for session 13 of 120C, 220C. Today we are going to go through and continue with the whole idea of how we can use list maps and other ways of looping through different values and really look at how that applies to some of the things we're doing in assignment 4. So we're going to look very carefully about the part in assignment 4 when we look at the issue of kind of varying some values and moving from just doing it in a very kind of intuitive way where we're dragging sliders to trying to automate that with using a list map. And then ultimately trying to figure out what the best value is that came out of that evaluation and then setting the model to use that best value. Okay, so hopefully we'll pull together a lot of things that people are working on kind of in the assignment. Everyone's examples are a little bit different, so we'll try to show two examples to just kind of illustrate how that might apply to your example. We're going to go ahead and revisit the whole sloping roof and just kind of finish the last step there of actually trying to pick the best value. But we're also going to look at this thing called a parametric surface, where I have this wavy surface which is defined by a bunch of curves that are lofted together. So if your example looks like that, we'll see how to apply a list map to that. Okay, and how we really all gets to be a game of how you encapsulate everything into a custom node and then work on what the inputs to the node are and the outputs of the node. So it's all about where you draw the boundaries. Okay. In terms of assignment 4, it is due this evening. We're going to have office hours just after class, like through the afternoon and early evening or something like that. I'll probably be here like 7:30 or 8, just however long people are here and want to come on in. Several people, especially some of the people in PBL, have asked for extensions and kind of pushed it around. If you're really up against the gun and have trouble finishing it up and you need a couple extra days, ask for it. Just let me know what's going on. And we're okay in terms of that. I know that with midterms and everything going on for the past couple weeks, it's been a really hairy time, so you may be a little bit behind. I'd rather you spend the time and kind of do it and kind of get the hang of it as opposed to trying to rush it all in there and like pulling your hair out at the end of the day. Okay, so, but if you can get it done today, all the better, and you're a little freer to kind of keep on going. So let us talk about where we're going with this. And really at a high level, what we're going to do is continue to look at list map, which is one of the major strategies we use for looking at a bunch of different values, versus while looping, versus kind of leading ahead to where we're going with genetic algorithms. And just as a starting point to kind of set the stage for what to, let's just kind of contrast really overall what these different approaches do. The idea is that you have some parametric structures, some input values that you can change, and then somehow the structure responds to that. Okay, and based on that, pardon me, we want to be able to evaluate any of your alternatives. And we could evaluate them on sun directness, we could evaluate them on the amount of surface area, we could evaluate them on the cost of building it. We can come up with any number of evaluation functions. And ultimately, we'll kind of probably come up with 4 or 5 different evaluations of a different form or a different structure. And you have different ratings along different sort of schemes. And we can prioritize them and work them together. Where we are right now is just really thinking about how to search for and look for different results that might be better than others. We're sort of searching a space because as we have a bunch of input variables, you really have a lot of different values you can go through and test. And the 3 major strategies we're going to look at are, number 1, exhaustive. Okay, exhaustive is what we're doing with list map. And with that, you have a range of X values and you say what the minimum is, what the absolute maximum you can imagine is, and just sort of divide up that space and just go marching through evaluating every one. Now, that is okay enough if your evaluation function is pretty quick and you have a lot of supercomputing power behind you. You can do that. As you sort of get a bigger and bigger space, though, it tends to get very slow. It's a very inefficient way. So it is very exhaustive. It covers everything. You're pretty sure you're going to hit anything that's of interest, but it takes a long time. It's not necessarily the most efficient. So in a simple one-dimensional kind of thing, it's probably an okay strategy. If you start thinking about 2 variables or 3 variables and how that all multiplies out, it really starts to get to be very, very difficult to go through and do that because it just takes an awful long time. So for every value or every pair of input values or triplet of input values, if you want to go through and do that for all of them, it could just really take a long time between iterations. Okay, so we look for faster ways of doing that, and that's what the last two are all about. Okay, while looping is a little bit like this. Okay, so while looping is like, it's just basically marching through a space and continuing to go until you find something that's either good enough or no longer good. Either way, so we're just going to go marching through while a condition is true. So we're going to keep on moving either while we're under some threshold that you think is okay and kind of find the outer boundary of where the okay is. Okay? Or we can go marching along until we sort of finally achieve something and say, okay, super, now we're in, okay, so we can stop. So a good example of where this sometimes can be used is, for example, if I have a maximum amount of sort of floor area that I can build in the building, and I'm varying the building form, and I'm twisting and raising it and stuff like that, as soon as I go through and exceed the maximum floor area that can be built, there's no reason to keep on looking. So for any possibility, I could only get up to that maximum floor area. Anything beyond that, I should just cut off. So while looping does that, it'll only keep going as long as you're either under a threshold or until you achieve some condition. Okay, so that's actually pretty useful too. You know, it's like if we were searching for gold all over the globe, okay, if we went exhaustively and we had to go through and search every location on the globe for the gold, that could take quite a while. Okay, while loop says, hey, as soon as you find some, stop. Okay. Genetic algorithms are the third and probably the most interesting way because it's kind of a hybrid between the two. And genetic algorithms use this. It's the idea of sending out scouts. So if we can go through and if the total space is throughout the room, if we sent out basically scouts just kind of randomly, some throw over here, throw some over here, some throw over there. Just put them all out there, random locations, and then basically everyone reports back. I got 10 scouts, everyone reports back. How good is their location? Okay, so Jordan says, hey, things are looking pretty good down on this end of the room. Okay, but Han over here is like, oh, kind of cold over here. Filippo, hey, things look pretty good over here too. So in my next round, when I send out 10 scouts, as opposed to sending them out randomly, I'm going to send 5 to Jordan's area and 5 to Filippo's area. Okay, and we'll do that a little more finely. Okay, and then it's going to turn out, Filippo's looks a little bit better than Jordan's. Okay, so then I'm going to send all 10 to Filippo's. So, and that's how you kind of keep on. That's how you go narrowing them down on it. But yeah, different strategies that sort of get you there. Ultimately, we're going to use all 3 of them. But we're going to finish up with some list mapping stuff today. Okay, so we're going to start with example 13.1, that whole sloping roof. That sloping roof is really based on the notion of changing a Revit model, but let's go ahead and pick up just the tail end of that. We've sort of gotten to the point where you've done a lot of evaluations. We even could write them out to an Excel file, but we're right at that point of, okay, how do I get the best? And then ultimately go through and set the model to be the best. So if you can, open up 13.1, which should look familiar to you. Let me come on over here. And if you can, let's start at 10A. We kind of made it all the way through 9A together. So let's just go ahead and start at 10A. Let me just kind of close this up, and I'll open up the same Revit model. It's probably already hanging around here in the background somewhere. Okay, that looks like my little slopey roof model. You might remember it. Right now, the roof slope is at 60. I think that's the last one I tested. Let's go ahead and open up Dynamo. And in Dynamo, we will start with 10A. That's the part where we've gone through, we've done the looping. We'll review that. Then we're going to go through and pick the best values.
How do you make a shaded surface come up and show up in the Dynamo preview? Like we
If
were
it's,
doing previously.
if the surface is selected, it seems to show up when you run it.
Yeah.
So all the surfaces, both the kind of evaluation surface and the shading surface, I think should show up.
For some reason, my evaluation surface isn't showing up.
Don't know. I'm gonna see if I can get Dynamo to show up. It's hanging around here somewhere.
Yeah, mine's the same, but it wasn't when on my other one, on my 12 stuff.
Do this. I'm gonna get a full screen just so I can get that reliably. Let's try this. Hang on. Pardon my flashing around here. Okay, Mr. Dynamo, where'd you go? I've got that. Dynamo thinks it's open. No, I'm gonna close Revit. Sorry for that. Let's see if we can start this up again. Okay, so again, what we are going to do, we have, if you want to look back on the left-hand side of the graph, we have all the logic for going through and using the list map, and what we were doing was just varying the range of roof slope values coming in from, I think it was like 5 to 60 or something like that, by 5.
Yep.
Okay. Let's let that come up again. Okay. Let's get this going for you guys. 13.1. That was the basic form. Here is the Revit model. Now let's go ahead and get that dyno add in. I'll open, go on out to 13.1. Let's start with 10A. Great. Okay, so 10A should look somewhat familiar to you. It basically started with the whole notion of going through and pretty much setting up the surface the way we had done it before. We had encapsulated a bunch of stuff into a custom node. We'll take a look at that. But the big inputs were either the model element, in this case a little slopey roof guy, the weather, the shading surfaces that we had picked because those weren't going to change, and the sun settings. So those things were all inputs. You'll see they're actually coming to 2 different nodes here. I actually have a couple different nodes because last time in class we actually changed this. So my original node was just going through and computing a cumulative insulation value, the total. Last time in class we actually went through and changed it around to use the density, and I like that a little bit better. So I just sort of plugged that value in again too. Again, what's going to happen here is the list map works this way. The list map says, give me a list of input values. In this case, it is 5, ... 60, ... 5. That's 5 through 60, incremented by 5. So 5, 10, 15, 20, all the way up to 60. Okay. Those are going to get list mapped to a function. And a function is just really any node that has an open kind of input. In this case, roof slope value is open, so those will get plugged in one at a time. Every time, every loop is going to go through and plug in that value, evaluate it, and then report the results. And that's ultimately going to give us a list of values back. Okay. In terms of what's going on here, for these inputs, and again, any set of inputs can work. In my case, I'm going to take roof slope value and input that and then update the Revit model because that's what this one does. Okay. In your case, you might be updating an amplitude, okay, feeding that into the node, and then it's going to go through and change a curve. It's going to get lofted. Okay. That's going to happen in the second example. So we're about to get there. But in terms of what's happening here, Mr. Jordan, what you got?
Just, I have a question. So on this custom node,
Yeah.
if you were to plug in a roof slope value, and then, for instance, give it the same type of thing for like different weather, and plug that into the function, you could do the same thing with weather on the same custom node. You just have to leave open the input that you want to be the function.
Correct.
Is that how the list map works?
Yes. Anything, yes. So if you want to have constant roof slope, then leave weather open. If you want to have constant weather, then leave roof slope open. It has one thing. Or what we'll even learn, I think it's the third or fourth example, you can actually feed them as pairs.
Gotcha. So what happens if your custom node has a default value for a input that you leave open? Where does it go to first? If it's plugged into a list map function?
It'll, well, if it had been plugged in any other place, it wouldn't go to this. This just has an input. It's an open input, so that's how it knows it's a function.
Okay, so it knows it's looking for a function. Okay, so we created, I'm just saying, like you could do this for non-custom nodes, right? You could do it for
Oh, yes.
like the solar analysis
Exactly.
function.
Oh,
But
so-
what I'm
so-
saying is there, what overrides if there's a default value
Well-
and you don't plug it into anything?
Oh,
Does it,
yeah,
does
no, I
it
understand.
recognize that
I
you plugged
understand.
into a list?
For example, the solar analysis for the rotation has a default of 0.
Yeah, that's what I mean.
That's interesting. Project rotation does work though, so it's interesting. It must go ahead, and if it's open, I think it understands it as being a list map before it tries to use the
Okay.
default value.
Okay.
That's a very interesting and subtle question. I'm not, it's like, I think it basically evaluates its proper functionality before it defaults back to the default. But good question. Okay, so in this node, we're hanging around here. If you would look at what's happening in here, and again, don't worry about that if you don't want to, because we've been here before. What we are doing is, if you're manipulating a Revit function, let me go way back over here. Here's where it starts. We're basically going to go through and say that there is some sort of input. The input was the roof slope value. It's going to feed into set parameter value by name, set parameter by name, roof slope. Because it's a Revit element, we have to do a transaction, start a transaction, because Revit has to update. If, on the other hand, you're varying a curve that is going to be lofted, you don't need to do that, because the curve actually will update mathematically. It doesn't sort of depend on Revit to regenerate. So even in the assignment, what we're going to do is sort of, well, look at that, separate a little bit sort of when you're generating panels in Revit versus when you're just using a curve and evaluating the lofted surface. Because the lofted surface doesn't need the panel regenerated every time. In fact, for every iteration, you'd be better off not to regenerate the panels every time, because you just really care about the value. You don't really care about the visual until maybe the end, where after you've chosen the best value, then you can panelize it and create the visual. Okay, so always watch out for what you're asking for on every loop. You want your loops to be as lean as possible. Okay, so it went ahead and did this. We chose our surfaces. At the end, it came over here to the solar analysis kind of node. And this is what Jordan's asked about right here. This thing has a default of 0. But actually, I do that in the second example of going through and varying the rotation. So if you leave the rotation open, it will take that as an input first. Okay, let's pop on out here. So basically, what this thing is going to do at the tail end is it's going to take the total insolation, the sum of all the insolations divided by the areas, and return that as some sort of a density function. So super. We'll go back out here, put it to work. let's go ahead and run this. And what it should be doing, although I should have used the principle of Dr. Hermonti over there and started a little bit lower, because I'm going 5 to 60. That's going to be not too bad for right now. Let's see what's going to happen here. Okay. Because the original node doesn't have any list mapped right here, there's nothing's going to happen there. It's just going to sort of sit there and be passive. Let's see what's going on. It looks like run has started. I like to go ahead and reorient my window so you can sort of see both things at the same time, because then you can actually watch the building dance in the background. Okay. It looks like it's actually doing something. Okay. So what it has done is it's returned a whole bunch of different values over here. It's list map. You'll see though, okay, so I got these values: 32,000, 325,000, 331, 342, 338, 348, 331, 339, 328. So I got some different values kind of hanging around over here.
Did you get those values?
Okay. For my model, I'm in spring. If it's, you might have to reset your sun settings, but it should be something like that.
Oh, I get nulls.
You get nulls? Let's take a look. It's almost always,
I
oh.
might just reload a node or something. I'm getting node.
You get a node. I did it first. Go ahead and open up the custom node. Okay. And now try running it again.
Okay.
That actually happened to me when I first read it this morning. So go ahead and try it again. No, I'm still there. I want to change something in the custom node. How about this? Go up to where your list map is a little bit different. And let's just try changing the boundary values on that. Make it just go from 5 to like 40 or something like that. Yeah, 30, because where we're going is earlier. I'm just trying to kind of goose it along, I'll call it, just to sort of see if it'll rerun. It says run completed again very, very quickly, so it doesn't look like it's really doing anything. So let's see if we can figure out why. Okay, so still a bunch of nulls.
That's
How
all
about,
set up the same. That's
yeah, let's try this. Let's reselect the surface. Just make sure you got the right surface selected. So back over on this side where it comes time to do that. Let's go ahead and change that. Did we get it? Try again. There we go. Now try running. And okay, data. It's still giving you nulls. Let's go ahead and see. It still says run completed and null. So I don't know if we're working on the same thing.
Yeah, 10A from 13. I can reopen it.
Sure.
I'll say no.
Yeah. Try reopening. Well, it should work there. Yeah, try reopening it there. You still getting nulls too? Yeah, it works. Okay, just took a
Was
second
your-
run or something like that, or?
Did yours give nulls before?
Mine did when I first started. Let's try just running it again, sort of see. Now, we can go into, you have values there? Still nulls. Go ahead and open up the function though. Let's see if we can sort of figure out where the function's failing, because often when these things are failing inside, you have to sort of do some watching to sort of figure out what's going on there. Zoom on in here, let's see what we have. We have surfaces, that's okay. List match with, okay, this is, it's giving me a null right there. So the analysis surface is right there. It looks like it's not matching that. Oh, I bet, this is one of those ones, I think that maybe the clockwork one is the one that's giving you trouble. It's basically where it's trying to match the surface, because you're getting a bunch of different values over here. You have the normal vectors, you have the maximum item, 0.73, and it matches one of these. This is actually returning the null right there.
What does that mean?
That means is that basically this function's not working for you.
Oh, okay, so I should open this.
Let's go ahead and try that. Ah,
Jeez.
turn into list is on, okay. Is clockwork loaded on this machine?
No.
Ah, that's probably it.
Okay, perfect. Oh my gosh, okay.
So
Right.
it's just buried alive in there. So sometimes you have to go digging deep to kind of figure out where it's failing.
And which clockwork? The 9.9?
0.9, yes. Try that.
Ah,
Okay, so bring that, and it should do that. Just so
sorry.
dig in. Oh no, that happens all the time. Okay, I got this list. This list is looking pretty good. It's a little inflated though, so I want to flatten it out though, because in terms of a list, I got numbers inside of lists. Okay, so that's kind of bothering me. So what I'm going to do is go through and flatten it by 1. That'll give me just the flat list, which looks a little bit better. So then I'm going to go out and just try and say, let's go through and find the maximum item. So the node's already there. If you go to the maximum item node, you can see the maximum one is around 348. So the idea is we just want to go through and figure out where that is in the scheme. Up here, we've taken and created this nice little data grid, which could be exported to Excel. You can sort of see that for the value of 5 as an input, it's 325 as an output, 10 to 331, 15. So looks like 348 is the 25. Okay, now we're pretty good at spotting that. It's a little harder to teach a machine how to do that, but what we can do is use the ever popular list match with key values function. And this is the one I sort of included it. Does yours show up like this? Value to be matched? Okay. That's the one we changed it the last time because we decided that it was a little confusing the way it was all worded. So let's go ahead. We're going to link this together. We're going to say the value to be matched, that's the maximum item. We're going to try and figure out which input has that. The keys to be matched again, that is really the list of values where you're going to find that. So where you're going to find that matching value. And that is actually, what is it? It's going to be the flattened list.
Yes.
Okay, now finally, it's going to go through there. It's going to figure out which index that belongs to. Then what I want to actually do is return the input value associated with that. So what I'm going to do is come on back here and say, let's go ahead and do, it's really the functions that got list mapped, or the values got list mapped, this list. Okay. So with any luck, you pull all that together, it should come back and say, hey, you match the input number 25. Let's see what it does. It's going to do a little running, it's going to do some flattening, hopefully it'll come back with a value of 25. Something's working. It's working, you know, okay, 25 right here. We were laughing about the little blue kind of spinny ball. On the one hand, the blue spinny ball looks pretty good because it looks like it's working. But there's this thing after about 30 seconds where you're starting to doubt the blue spinny ball. So there's this funny thing about your relationship with the blue spinny. Okay, 25 looks at, woohoo, we have found our maximum. Okay, or at least the maximum of the ones we've searched. So within that now, we are ready to go through and say, great, it's 25. Make my Revit model look like that. Okay, so not to worry. Here's what we want to do. We want to go back, we want to set that parameter value by name, yada, yada, yada. That's what really we're after, is just basically taking that input value and just kind of plugging it on in. Okay, you can do that in a number of ways. You can just go ahead and say element set parameter value by name and kind of plug in the 25, that'll do it. If you want to panelize it and do all that type stuff, you can put all that stuff into a custom node. Yeah, so you can do all these fine things. In our case, we don't need to panelize this little flat surface, but the idea is go ahead and separate in your mind the evaluation, which should be a very lean function, just enough to kind of get the values out, okay, from the ultimate rendering of it. You know, so setting the final value, panelizing it, colorizing it, whatever you're going to do. You kind of think those two things are separate, because you don't need to, if you're not going to use the panels to evaluate the surface, you're just going to use the surface itself. You know, you can delay all that, and you don't have to regenerate that every time. Okay, so the quickie here is we could go through and just say set panel by name and do all that, just kind of put it in here. But let me kind of show you a trick, because here's a trick that actually works out pretty well. It turns out that often in our big old custom node that we created, really almost all the infrastructure you need is in the custom node. So let's come back over here and take a look at this custom node. This guy over here is kind of interesting to us. And the reason he's kind of interesting is that it had variable roof slope value. Now you have a specific roof slope value. So a really quick way to sort of get this is just to take that function that you were using to value it all the different times, and actually just pop that value in. Okay, that'll give us, again, the insulation density. We've already computed it up here, so we can just grab the value here. But if you want to go through and change this node and put the panelization in here, or put the overriding the color in view in here, whatever it is you want to do, you can. But the nice thing is this node basically already just needs that value plugged in. Okay, and it'll go through and reset in the model of color. So this will have a little extra kind of solar calculation at the end, but that'll basically tell you what the cumulative insulation density is for that value. Okay, and you can move forward from there. Okay, so just keep track of that node. We'll use it in a slightly different way with wavy curves, but that node is really useful to you because it not only is a great evaluator, it's also a setter. Okay, but again, watch for your nodes, especially relative to the assignment, keeping your evaluations separate from your panelization. Okay, because that can be a little bit easier.
But we already have that value in list max and item. Why don't we just take it from there?
Oh yeah, exactly. We can just get it up here. It's actually, it's right there. Yeah, no, we can get it there. No, this would really be more about just resetting the shape.
So we set the shape.
Okay, but again, you don't need to do it this way. This one's actually probably a bad example because I could just say element set parameter by name. Actually, let me do it this way. What I'll do is I'll just take this guy. Let me edit it for a second. I'm going to edit my little custom node. I'm going to just do a save as. I'm just going to say this, call it like set optimal shape and colorize. So within this, all I really need, if I'm just going to use it to kind of set the optimal shape, is I can get rid of all this. I can get rid of a lot of stuff down here. All I really want is this first part right up here. I can get rid of a bunch of other stuff here. Actually, it's hard to get rid of a bunch of stuff unless we put it in a group. It's hard to do a massive delete unless you select them all. You can group them, and then you can delete the group. A trick there.
It's weird that you can't select them and then just hit delete.
It is weird.
I've tried to do that many times.
Okay, so I get rid of these things in there too. So this is just one that it takes the model element, it takes the roof slope value and just sets it. But again, it could be doing some other stuff in here too. But kind of separate that. So let me, before we go to the next one, just look at the assignment again so we can kind of really get really fine in your own mind about exactly what you're doing at the different pieces. Is it up here? I don't think it's up there. Probably here. Okay. So great. You're evaluating the directness of the sun on the panels and providing visual feedback. I think most of you are in really good shape on that. Do that, put some panels on there, override the coloring view. Okay, evaluate the solar potential. Great. Okay. Use the solar analysis package to calculate more accurate evaluations. Okay, do that, compute that, vary the input parameters, again manually. Provide visual feedback through surface panel color or parametrically determined panel features to rank and adapt the color. That's a little tricky in terms of doing that because the color node is not working so well. So set the input values to these optimal values. I guess I would say for this even, go through and after you sort of figure out what you think the optimal value is, go through and set it using the panelization that you're already doing and the overriding the color in the view. You know, so go ahead and just do that kind of the way you want to there.
So for that, can we make a custom node from the old example we used from 4A and then put that custom node in the set optimal shape and colorize custom node?
Yes.
Okay.
Oh, exactly. That's exactly what you should do.
Yeah.
So whatever you did right up, up top in terms of colorizing it, you just want to do that at the tail end.
Mm-hmm. Yeah.
Yeah. So after you figured out what you think the shape is, use it. Beautiful. And that's really the same thing you're doing down in here. So list map is great to quickly evaluate a range of input parameters. So this is go through and you're making that node, okay, find the most influential parameter, exhaustively test a range of values, okay, set this input as the optimal value and provide visual feedback on that. So the only difference really between 4 and 3 is really, for 3, if you're doing it for 4, you've really done 3. For 3, the really idea was that people who don't want to sort of play with a list map and just want to sort of try tweaking the input values can do it that way.
Can we just do
But
a
if
list map though?
What's that?
Can we just do the list map thing now?
Oh, yeah.
It seems easier.
Oh, no, exactly. It's really, all 4 does is it just really automates step 2 there. Yeah, it's the same thing. It's just really whether you do the automation behind it. But again, set up the node to do the automation and then set it after it. Okay, so we'll next look at an example that separates those two a little so you can sort of get the idea of how that works. And it is, let's pop on over here. It's really this parametric surface over here. This is one where we go through and we start by creating a lofted surface. Okay, we just sort of finished up looking at that last time. I panelize the surface, that's okay. Then I want to do a solar analysis on the lofted surface. Okay, use a list map to change that. At the end, I would like to basically panelize the final shape. Okay, so let's look at that. We'll try to sort that out in our brain. Okay, so come on if you can over to 13.2. See if I can find it on my machine. Okay, let me close up this one. Close up that one. Because this should be right up your alley. So just building this example so it looks familiar to you as we dive on into it. What we're going to start by doing is just lofting together some different surfaces. So go ahead and if you can it's probably 1B or something like that. Let me see if I can find it. Let's just take a look at that. Open this up. What do we got? Let's go to 1B. That's creating the lofted surface. If you want to, you can even go to 2B. Let's just go to 2B. 2B is going to be fine. If you're already in 1B, just hang out there. Basically, this all starts with the notion of just creating several different curves and then ultimately lofting a surface out of them. And that's probably pretty familiar with where you are. And I have all these different amplitudes. I have number of waves for the waviness. I have this length of the surface. Length of the surface was something where, oh, I could go ahead and make it 50 feet long, 100 feet long, 200 feet long, stuff like that. But it's all about just kind of creating this little wavy surface and ultimately going through and panelizing it. Now for panelizing it, let's just start with creating the wavy surface. I'm just going to take off this connection right here. That'll just create the surface, and it won't do any panelization because the panelization is broken right now. Okay, so if you want to check this out and go ahead and run it, this should create some sort of wavy looking thing back there in the background. Now, even in terms of how this is done, this I have a little custom node in here just because I figured out, hey, this sine wave curve thing is really kind of useful. So if you want to take a look at that, this just basically says, if you give me a length and a number of points and a number of waves and an amplitude and a base height, I will return for you these different curves that I'm going to loft together. So I just made that a custom node just because I was going to do it 3 or 4 different times. But it's really all about creating these 3 or 4 different curves. And then if I go through and use that back over here, for example, I think right now I have 4 waves on each of them. If I change that to the middle one being 3 waves, and run that, I get a sort of a warpy surface in there. 2 waves. Even in here, I can change the length of it over here. So right now it's like 56. That's an interesting length. Let's say 100. So the idea is, these are what I'll call my big input parameters. I can change the length, I can change the waviness, I can change the rippliness, the height of the waves. I just have different things I can change. Okay, so the first part of it in terms of panelizing it, which most of you did already, just take that lofted surface, and all I'm really doing is taking that lofted surface and I'm dividing it. Actually, there's a couple of Lunchbox functions to make this very quick. I can divide the surface into UVs, okay, and return the points and quad the points. So that's actually a very efficient way of doing it. If you like the Lunchbox function, you give it a surface, you give it a U and V number of divisions, quad the points, and then ultimately just apply the adaptive component to it. So that's like a real quickie. Okay. There's actually another function, sort of another one even built in. I put it in there just because it's kind of cool, quad grid by face. So there you give it a surface, and it actually just returns the panel points. It can also return the faces. So it's, you know, the Lunchbox and Clockworks are beautiful things. They have a lot of good stuff in there for you.
The one up top, the surfaces dot divide surface UV, is that Clockwork or is that?
I think they're both Lunchbox.
They're both.
If I am remembering, why did I take that back? Is it? Let's see.
That's okay.
Yeah.
Yeah.
Surface dot divide.
Why
I
don't you
should-
use Lunchbox? I did
Divide, surface dot divide, surfaces. Gotta hate that. Looks like that's Lunchbox also.
Okay.
Okay, so either one of those will panelize it. So the idea is you could just go through and take that lofted surface and bring it on down there and use either one of those. And that'll go through and create some sort of panels on it.
My sine curve custom node is failing. Why
Really?
did That doesn't make sense.
Which one?
There's nothing in there. It's just code blocks.
Your what's not working?
My curve dot sine wave.
If something's really kind of breaking that way, you open it, try replacing little cheap pieces in there, or actually just, you know, quit Dynamo and come back in. A lot of times, little things like that happen and just really mess us up.
I can just replace it with a new one probably.
What is this? This is, I got this like adaptive seamless panel. Let's see if it actually worked. Should be over here somewhere. There it is. Now realize, just in terms of looking at my surface versus the panelization almost necessarily gives you a less precise answer. And it's what really happens. At some level we can evaluate the true curviness and the true insulation available on that curve, but we tend to panelize things based upon what could actually be built. And if we go through and evaluate it based on the panels versus on the surface, you'll actually get two slightly different results. If you panelize it finely enough, it'll approximate it, and it'll get very, very close. But you can see that the panelized surface is a little bit rougher than your true surface. Yeah, so the solution is the more U's and the more V's, kind of the finer it is, the closer we'll get. But the reason I tend to sort of just use the surface is that's a really quick thing to evaluate. Whereas if I have to evaluate all 100 panels, that's a lot more kind of calculation in the background. So you just got to sort of figure out what the value is or the difference between those two things. Okay, so what I'm going to do is I'm going to go after just the surface itself and try playing with that. So what we did in the next step, if you go on over to, let's go to 3B, the solar analysis on the lofted surface is, you notice all this panelization stuff, I've kind of just abandoned. It's kind of hanging here, it's waiting for me. I'm going to get back to it later, but it's just kind of hanging over there. So what I'm going to do is take my lofted surface and take my solar analysis. So I'm taking that as an analysis surface. I don't have any shading surfaces. I have some time study stuff. I have some colorization stuff over here. All these things are kind of good. This could be for the single lofted surface, okay? And you can run it that way. So if you run it that way with any luck, depending on how things are working, yeah, this is probably where you guys are. So let's just go ahead and try running that.
Or you can put list not empty for if you don't want shading surfaces.
Yes, oh yeah, it defaults to, yeah, list.empty would be no shading surfaces.
Okay, I was wondering.
Okay, so there's my little colorized thing in there. So we can go ahead and now to see how this could respond, I could go through and change the waviness, I could change the flatness, we're going to change the rotation as something to go. Let's think about something we're going to vary. For example, if I was just looking at the total amount of insulation, just making it bigger would probably take care of that. You know, there's all an easier intuition about what would actually work. Okay. But what I want to do is basically construct a function that will go through and for any sort of variation in the whole scheme, allow us to go through and change and reevaluate that. So this function can have a lot of different inputs. We can, for example, well, let's just kind of sort it out in terms of what we need.
So your point is to have a function that won't only solve for project rotation, but would also solve for weather?
We can do it to change the weather. Anything that we leave on the output of the function, as an input to the function, will be something that we can kind of change as one of the input variables.
Yeah.
So let's do this. For my purposes right now, I'm just going to knock out the colorization because the colorization is just going to get in the way for what we're doing right now. So I'm just going to take it out for now. So, or if you want to, just put it off to the side somewhere. We just don't need it. So here's the idea. I got my beautiful little evaluator kind of hanging around over here. Currently, this evaluator has an input of, it has the time, it has the weather. Okay. This is all my little panelization. I'm not even going to worry about the panelization right now. So if you want to just go through and pull that over, let's just get it out of the way. Just so you're not even looking at it. Because graphically, we're about to kind of do a big old swoop in and kind of grab some different things. So the idea is we want to take anything that wants to be inside the function and get it together. Anything that's outside the function will get input and kind of separate them. Just because we're going to grab them all. So for example, these guys over here, the weather and the time, I'm just going to shove it back over this way a little bit further. And this part over here where I create the surface, I'm going to pull that closer. So So here's the part, Miss Diana, that you need to kind of play around in terms with understanding what it is that's in and out. If you want to, for example, change the waviness as one of your input parameters to the function, just go ahead and, for example, if I want to go through and take the number of waves in the middle, for example, let me just try that and make that. I'm going to just basically remove it from the group just so I can pull it over here. I want to get it outside. Okay. By putting it outside of the function, then it's going to be an input parameter. So it'll always have to be filled in. It'll get filled in by a list map, or it'll get filled in because we just sort of stuff a value into it. So anything that you want to have the ability to change, pull outside of the function, anything that's going to act on the input values you pass in, leave in the function. Does that make sense?
So you don't even have to unclick it from sine, curve, waves, and amplitude. You just have to ungroup it.
Oh, we're going to pull it over there only because I'm about to make a node out of it.
Oh.
Okay, so it's still not doing it. It's all just kind of, I'm just sort of graphically kind of sorting it out so I can group everything and do a big old kind of make a node. So pull anything else you want out. So for example, the one that I was actually going to use was project rotation. That's already a hole right now. So if I make a node, it'll show up as an input just because it's understood as being an incoming hole. Okay, I could go ahead and just put an explicit, it'll make an input value for it, or an input node for it. But anything that's an upstream hole will be generated as an input. Anything that's a downstream endpoint will be an output. Okay, so let's go ahead and, I'm going to do that middle one there, number of division points, that's not, how about the edge 2 amplitude? I'll go through, no, let me do the amplitude at the outer edges. So another input value could be, again, I'm just going to remove this from the group, just so I can shove it over here. Beautiful. So now I got all that stuff in the middle. And the stuff in the middle is about to get replaced by a custom node. Okay, so inputs, outputs. This stuff's going to hang out over here because it's going to use the output. So let's go ahead and just do a big old drag all the way around, all that stuff. And that's why I was just sort of sorting it out graphically. Just makes it easier to do my drag. Oops, before we do anything, save. Always save before creating a custom node, just because if there's anything that's likely to crash you, it is this part. Actually, I should take that back. A year ago, it was definitely true. It was like, when you created custom nodes, it was like, all hell's breaking loose. So it's like, I think it's a little bit better. So go ahead, do a save out of that. Save, save, save. Save as 3B in progress. Okay, grab that guy. I wish you could right click. This feels like it should be a right click, but it isn't. It's up here. Create a node from the selection. Okay, what's this going to be? This is going to be my, this is going to be my surface. Again, it's usually sort of the noun, what you're acting on. Surface dot evaluate soar potential. Okay, I'm going to put that in my CEE 120 category, just so it sure shows up in that part of the browser. Say OK. What happened to all my work? That's why you have to save beforehand, because it's like, you don't want to lose it. Okay, what a pathetic little function there. But it's going to be so good to us. Okay, so here it is. I have number of waves, wave amplitude, weather, time steady. Interesting, notice that it didn't go ahead and give us an input on the project rotation. I think because it has the value of 0, we're going to add an input for that. That's interesting. It didn't do that automatically. Okay, but let's do this. Because we like our function so much and we want to find it in a few minutes, We're going to edit its custom node. Take a look at it. This should all look pretty familiar. It's just everything that used to be inside there. But what I love to do is do a save as. And save as, again, to the same folder where your example is or where your assignment is, because you need to go ahead and kind of make it really easy to find later. Because if we can't find this, we'll be in trouble. Okay, this node is so wonderful, you can share it with all your friends. Think of how much Mom's going to have fun she's going to have playing with this. She's going to
Or you just, how do you save these? Oh, save as. Just
I just save as. Okay, so the number of waves, check. Actually, and even number of waves and wave amplitude, check. That's actually, you can be very precise about what's going on here. For the number of waves, if you don't like the description right there, go ahead and make it a little bit better. Number of waves, middle, curve, wave amplitude, edge curve, weather, time study, that looks pretty good. Let's pull them down just so it's a little easier to find them. Now, just because project rotation looked kind of interesting, I'm going to go through and create an input for that also. So I can say, oh, just input. Go ahead and just call that the project rotation. Pop that in there. Then, just as a matter of convention, I tend to pull my inputs way over here. I'll say project rotation for solar analysis. On the output side, let's check a look at what you have available to us right now. It really just took all the open downstream things, so let's see what we have. We should probably label them. These will be the output nodes, and we can get rid of anything that we don't really want to have evaluated. For example, what am I returning right here? I'm getting the cumulative, okay, evaluation point, or the cumulative installation points for the whole grid. If that's what you want, super. If you want to flatten that, or you want to compute the average, whatever it is you want to do to it. Actually, for this, it probably would make sense for us to go through and flatten it and compute the average or compute the total or something like that. Because really, I would like that to be done for every iteration, as opposed to just returning a bunch of grids. So either one of those could work. If I'm going to do that.
Does an average already do that, or is that average
That's
for
the
a specific
average.
panel?
That's the average insolation throughout the year.
Okay.
So it's not like the mathematical average. So if I was going to do that, let me just go ahead and I'll just say list dot flatten. So I'll take that, I'm going to flatten it by 2. That'll just give me all the values. Let me remove that. Actually, I can use it in a second. And then I'm just going to sum those. This is not a density. I'm just going to get the total amount of insulation, which would work for the rotation. It's good. You got to think about just really what you're getting. Okay. Then I can say math sum, or I can make something much more interesting in here. Okay, so this is going to be the total cumulative insulation. I can get rid of anything I don't like or don't care about outputting. Or keep them if you want to get them later. Okay, let's just save that away. Let's go back out and take a look at our little node here. So here's our fantastic little node hanging out. Okay, it's got project rotation, it's got wave amplitude, it's got total cumulative insolation. We are in pretty good shape. We are ready to just run it, right? Plugging things in there, and with any luck, that would give us the same evaluation. So if I took all these values, I put a 0 in here, that should give me exactly the same number I used to get. It's just sort of all put together as a node. So if I, for example, put a 0 right here, that is just the same as it used to be. So if I watch this at the back end, again, using the homology principle, start simple and see if you get predictable results, and then go ahead and start varying up. Okay, so this is it for the project rotation of 0 for these number of waves, this number of edge curve amplitude. If we go through and change those things manually, you should be able to sort of see some results that would be sort of intuitive in terms of playing with that. Say what? Okay, is everything filled in?
You're not project rotation.
If it tells you function, that means something is still open. So I have to put the 0 in there to plug it.
Same thing to me.
So if you're going to evaluate it straight on, plug all the holes. If you're going to use it as a function, leave one open. Okay, so this is looking good. We're now ready to do a little list mapping. For list mapping, just go ahead and kind of set up a list map and some range of input values. So list map. Okay. In terms of the function, go ahead and pull that over. The list is whatever it is you want to test. If you want to test a range of rotations, we'll put in a range that sort of makes sense there. We could say, oh, let's go 0 to 90, going every 10 degrees. Okay? So we'd put that in as a list, and then we would leave rotation open. Okay? That would go through and give us the list of all the values for each of the different rotations. If you prefer to change the number of waves or the wave amplitude or something like that, put in a range there, and just always make sure there's one hole. So again, if I was doing that, if I was going to go everywhere from a wave amplitude of 1 to a wave amplitude of 10 by 1, I would do a list here. And instead, I would plug the project rotation and leave the wave amplitude open. So either one of those work. It's just sort of a matter of which way you like. Okay, let us pause there and say, oh, is it 7:45? Yeah, we'll still do it. Let's go ahead and take 5 in terms of what's going on, and we can answer some questions if you have them, or if you want to run this, we can try that. But that's really the essence of it right there. Go through, get that, so you can keep all your curve functionality and lofting the curves inside the node, and then out of that, you get a value, and we'll match the value to the input and what we did at the tail end of the first one, and then ultimately set the thing so it matches the maximum value.
Again, what caused the visualization to disappear?
It's so weird. If you plug 0 into project rotation for solar analysis, the visualization pops back up. But when I run it with it, it's all good. But the minute I leave that blank
Oh, that's interesting.
and run it as a function, so look, there it is. This is so cool. Watch. Then it just goes away. I think it's it running like a function. So I think that you could do some pausing. I think it's running this, and then this doesn't know what to
So
add in.
as soon as you take it out, it's doing it as a function.
Oh yeah.
So
When
then
it does
it
it as a
doesn't.
function, then all the colors go away. But as soon as it's not a function,
Well, it sort of makes sense that as a function it won't do it, because as a function it'll return a whole range of values, or a bunch of surfaces, and then it doesn't return like a single surface. Like,
Oh, okay.
okay, but again, we just gotta play with it in terms
Because like the
of
whole thing just went away from me.
Yeah, well, just because out of the function, out of the list map, oh, I'll tell you what's going on. No, it's even this is sort of understandable. In the list map is really just going to return those values. Surface, I bet, if we watch that, doesn't really have much to it. Go ahead and watch it and see what it is. I think when you're running a function, I don't think that actually returns a value. Let's see if it does.
That would make sense because all of this thing together.
So it just says function there?
Yeah.
Yeah, so it doesn't know what to do with displaying the function. If you hold out the surfaces as opposed to pulling out the cumulative insulation values, you could probably colorize one of them. But again, it only wants to colorize.
Didn't I do that by pulling out this surface?
But it's on the list. The thing that will be pulled out is determined by whatever the list map's grabbing. So it only pulls out the thing
Okay.
that the list map's pointing to.
Okay.
But
So
I think
how can you even reference the actual surface?
the thing
Once
to
you
do
have a
is,
function?
after we've gone through and done the list map to find the max, then we'll go through and do it not as a function, we'll do it with the set value just for the one value, which is the one you want to use.
Should we just make a new surface then?
Oh no, you can still do the same surface, but basically use the list map to go through and find the value of the input, the value of the rotation or the value of the waves.
Okay,
And
yeah,
then-
this watch.
And then out of that, we'll go through and just match that to one of the inputs. And then create that as an input. It's basically you want something, yeah, you want to basically do it for the last case. It's kind of like the roof. After you're all done doing the looping, you want to do the one last case, which is actually generating a single surface.
Okay, so
How do you-
here, if I want, here, this is my insulation, so I want the max, so I pull the max out of here,
Okay,
and then that's going to be,
okay, then, you done?
yeah, but then but that's just gonna be max of total cumulative insulate. Oh, but then I could get the number within the list and then come back
Exactly,
find.
and then we'll basically match it to which of the value of the input parameters gave you that.
Okay, okay.
And then we'll say, okay, let's generate a surface based on that input value and get a visualization for that.
Okay.
Got
So
it.
you just go.
So after you go through, it's kind of like what we did at the tail end of the slopey roof, right?
Yeah,
So
yeah.
do a list map, get the max, we'll find it against that, and then we'll say, great, now we're gonna rerun it and just do the solar insulation, including and pull the surface out this time.
Oh, so you just duplicate the surface value and solar potential in this case, or you could cut down a little bit, either way.
Because when you run it, as a one item as opposed to the range, the last time you run it, you're basically just returning the surface and you're colorizing the surface.
Yeah. So that's what you wanna do, is you wanna take the basically custom node that we edited to do the solar
Yep.
radiation. You wanna get rid of the solar radiation, you wanna create the surface, you wanna colorize the surface and set it to the optimal slope and then colorize the surface.
Exactly.
And then display it at the end. And
Exactly.
It's only one more run with a few more things, but you're taking out the solar.
Yeah, so see, the first time you're doing it all quickly, and the last time you're doing it and giving the visualization at the tail end.
Right. Cool. I think what I'm gonna try to do is I'm gonna try to create a facade
Mhm.
and vary the tilt
Mhm.
and waviness a number of sine curves. So that it would be like, what is the solar insulation?
Mhm.
Basically, what's your solar load?
Mhm.
How does it change when you tilt it? And we're changing the curves.
Mhm. That's good.
Quick question.
Yes.
If I created the rungs in this as well, should I leave that for later as well?
Leave it to the end.
Okay.
Because really, everything about the final articulated surface, just save it after you figured out the best surface values.
Okay.
And then so all that, right at the end.
Okay.
Give it a- amplitude, okay. And you're going for a series of wave amplitude 1 to 10, okay, that should be fine. Let's take a look at this. In terms of what it's returning though, it's just returning -1. So let's look inside this function. We'll figure out what's going on. So if it goes anywhere from 1 to 10, oh, let's take a look at this. That's just true. It's a very slightly different notation. Let's try leaving out the space. Yeah, let's try it. For whatever reason, evaluated to true. 1 to 10. We don't want that to be true. 1, 10. Those look exactly the same, so I don't know what the difference would be. Oh, now it kind of crashed because something was just a little bit confused. We should do a save as. Just to make sure. We might have just to restart. Yeah, just restart Dynamo. I think that node is just very confused right now.
I'm not there yet. I'm trying to move my stuff around so I can
So once you have your cumulative maximum insulation,
Mhm.
how do you trace that back to find the value of the input that you solved for with the function that gave you that max?
We'll go through and use that list match keys function.
Ah,
So we'll take the max and the list of all of them, and then we'll get
Yeah.
the list of inputs and match them up that way. See if I can get to that same spot with you.
sweet. Key, yep, cool. And we just use sequence, we don't use values, we use, well, okay.
Yeah.
Okay.
Yeah, I am running it right now, just to try to see if we can kind of put this final piece together. I think most of you are right on the edge. You got it. This is right there. You can touch it. Oops, I'm still recording.